Apparently we're doing this video in 2 parts. Sorry. My cousin called me and he's stuck in Vegas and I might have to go get him later. So, 2-part. We're going to go to simplifying, multiplying, and dividing roots. I showed you how to I told you how to simplify a minute ago. Simplifying is relatively easy. I liked it. So, let's try something where we already have a number on the outside, but let's simplify what's in the radical and see what we have to do. So, if I'm given 9 square roots of 75, I need to break down the 75. Breaking down the 75, I know I'm thinking about it as money, which kind of like made the kids think a little bit better about it. How many quarters does it take to make 75 cents? Well, it takes 3 quarters, and quarters are worth 25 cents. So if you know your roots, which is why I said know your perfect squares. If you know your perfect squares, we already know that we have a perfect square right here that we can pull out. But if you don't, we know that 25 can split into 5 and 5. So knowing that, we're going to pull a 5 out. But since we have a 9 on the outside and we're pulling a 5 out, what we have to do is do 9 times 5. Well, 9 times 5 is 45, and we have a 3 stuck on the inside. So it's 45 square roots of 3. So that's pretty much what we're doing here. It's relatively the same thing, except if there's a number on the outside, whatever you pull out needs to be multiplied by that number. It's the exact same thing. So it's just one extra step. So now what if we're given the square root of 6 times the square root of 3? Well, what we're going to do is we're just going to multiply 6 times 3. Well, multiplying 6 times 3 is 18. And then let's simplify. We know it can be split into 6 and 3, obviously, and this can be split into 2 and 3. So we're actually pulling a 3 out, and we get 3 square roots of 2. There's also a simpler way to look at it, which sometimes I would get in trouble for teaching kids, and it kind of frustrated me when I would teach it this way, but it took out an entire step. So if we know we're multiplying, I would just be like, well, we're just multiplying, so just extend this, because I already know I'm multiplying 2 radicals together, so I just extended the radical, and then I didn't have to multiply that to get the 18, because that's just an extra step I don't need. And then I just simplify right here, because I'm going to get the same answer. I just didn't need to write that extra step. I got in trouble for that because one of the teachers didn't like the way I taught it, but a bunch of the other teachers were like, that's fine. It is fine. I feel like that's a simpler way to explain it. And then we're still going to get 3 square roots of 2. I just cut out an entire step that kids were like, why is the way you teaching it so much easier than putting that extra step in? Because that's just like super redundant. I'm like, it is. So I taught them how to do that way, and it was a little easier for them. So that's all I have to say about that. It's a little bit easier for people to understand that. So that's multiplying. You don't have to have matching bases to multiply. So let's see if we get one like this. 2 square roots of 10 times 3 square roots of 14. So looking at this, I'm just going to multiply the outside numbers. Well, the outside numbers, 2 times 3 is 6. And then I'm going to extend my roots. And I'm just going to do, 10 times 14 because that's under my radical. Because I don't want to multiply that because then I get 140 and I have to split it. Because splitting it into 140, you're going to split it into 10 and 14. What's the point in multiplying just to split it into the exact same numbers? So what I do now is I'm going to do 5 and 2 and 2 and 7. Well, where's my pair? My pair is the 2. So I'm taking a 2 out. 6 times 2, because there's a 6 out here. 6 times 2 is 12. And 5 times 7, because that's what's left underneath the radical, is 35. And that's our answer. So, let's move on to a little bit of division with this. So that's multiplication. Multiplication is relatively easy, right? So let's move on to some multiplication, or not multiplication, division. So if I'm given 24 over the square root of 3, so square root of 24 over the square root of 3. Here's another way to look at it. They're both square roots, so let's do this. I'm going to extend that like this. So now you don't have to freak out and be like, there's a square root in the bottom. The entire thing's being square rooted. So what we have to do, just do 24 divided by 3, and 24 divided by 3 is 8, and still underneath the radical, and then just split it. And we have a pair, so now we have 2 square roots of 2. That's a very easy way to look at it. You don't need to panic when you see something like this. People tend to panic because they're like, there's a square root on the bottom, what do I do? I'm like, well, if there's one on the top, extend it, it's fine. It really is fine. I promise, life is fine. So if I'm given one that's square root of 40 over the square root of 2, again, let's extend the square root. So 40 divided by 2 is the square root of 20. Let's split this into 5 and 4. And if you know your square roots, we already know that the perfect square right here is 2. So I'm taking a 2 out. So 2 square roots of 5. Right? See, this is not super difficult to understand. Multiplying and dividing roots is actually quite fun. But now we're going to move on to adding and subtracting roots. This is a little bit more difficult, but really not that bad. I don't know why I decided to try to put my eraser over there. So, let's look at an easy one right now. So if I'm given 5 square roots of 13 plus the square root of 13, this is easy because bases already match. We have to make sure when we're adding and subtracting, our bases in the radical have to match. That's the goal. This is the only way we can add and subtract something is the bases have to match. So all we have to do here is we're just going to do 5 plus 1. That's it. The bases won't change. When we're adding and subtracting, bases don't change. So we're just doing 5 plus 1, which is 6. And it's just the square root of 13 because the bases match. That's the basic of this. So that's our easy portion, as the bases already match. So let's move on to one where the bases still kind of match, right? So we have 7 square roots of 2 minus 15 square roots of 2 plus 8 square roots of 2. So you should know oh my gosh, my brain just broke. You should know order of operations. Where it's please excuse my dear Aunt Sally. But I like to draw these little things here. Because multiplication and division and addition and subtraction are on the exact same level. So if we're looking at this, we actually read it left to right. So if there's a subtraction before an addition, you have to do the subtraction first because they're on the exact same level. You don't just go straight to the addition because that's going to change the entire answer. So we read from left to right. So what we do first is we do our 7 minus 15, which gets us to negative 8 square roots of 2 plus 8 square roots of 2. And then add those together, get 0. Just make sure when you're doing order of operations, parentheses and exponents always have to come first. But if you have a division before a multiplication, this is where those things on like Instagram and Facebook come up where you look at these problems and people are like, no, probably the answer is 0, or the answer is 8. Because people are looking at something like 8 divided by 4 times 2, something like that. And so like, no, the answer is 1. And the answer is, no, the answer is, okay, hang on, 8. 8 divided by 4 is 2 times 2 is 4. So some people are like, no, the answer is 1, no, the answer is 4. But in actuality, the answer is 4, because 8 divided by 2, or 8 divided by 4 is 2, and then 2 times 2 is 4. But people are doing 4 times 2 is 8, and then 8 divided by 8 is 1. But you have to read it left to right, because that's what order of operations is. Even though the division is first, and people think multiplication has to go first, they're on the exact same level, you just have to read left to right. And that's where some people get confused, and then it's a huge fight on Facebook and Instagram, and I have to sit there and stay out of it, because then I get frustrated. So let's look at one where the bases don't match, and we have to kind of make them match. So if I'm given, I need to make sure I find one that's actually going to match, because there's one on here there's one that one doesn't. Okay, so let's do this guy. 3 square roots of 75 minus 10 square roots of 27. Well, right here we already know we can't just automatically subtract because our bases right here are not matching. So that's why we need to simplify our roots. That's why I taught you a little bit ago how to simplify. Well, we already know this one because it's quarters again. So 3 and 25. Well, this one is 3 and 9. It's 27. 3 times 9 is 27. Well, right here, I see perfect squares, which is 25 and 9. So I know that I can pull out a 5 and I can pull out a 9. Well, 3 times 5, because I pulled out the 5, is 15. And I'm left with 3. So 15 square roots of 3 minus, I'm pulling out a 3 here. So 10 times 3 is 30 square roots of 3. Well, now we can actually subtract this because the bases are now the same. We have simplified enough that our bases match. So what we have to do is just do 15 minus 30. And 15 minus 30 is a negative 15 square roots of 3. The whole goal to add and subtract is your bases have to match. If they don't match, you can't do anything with it. So let's say I get one, like the one I was about to show you first. So let's say I get one like this. So it looks something like this. And we're like, well, let's simplify because I want the bases to match. I need them to match. So simplifying this, I know it's 5 and 4. And here's my perfect square. So I'm taking a 2 out. So 2 times 2 is 4 on the outside with a 5 on the inside. Here, I'm taking out, what did I take out? I did what did I do? I did something wrong here. I did something really wrong there. Hang on. Right here, I'm going to take out a 4 and a 6. Here's my perfect square, right? So 2 times 3 is 6 square roots of 6 because I can't do anything with that 6. Well, I can't do anything. I've simplified as far as I can, but I can't do anything. So I can't subtract. So this is actually my answer. If I can't do anything and I've simplified as far as I can, this is your actual answer. Like, there's nothing you can do. You've simplified, and that's it. You're just stuck. So if you see that and you panic thinking, oh, what did I do wrong? You did nothing wrong. You just can't solve it because the bases will never match. And that's not your fault. That's the problem's fault. So let's try one like, try this one. 3 square roots of 12 plus 3 square roots of 11 minus 6 square roots of 11 plus 2 square roots of 12. So looking at this, I'm going to combine my like terms first before I simplify anything. Because I already know for a fact that the 12 and the 11 will never ever match. Because 11 is a prime number. Can't get anything out of it. So I already know that I can do this. What's 3 minus 6? Well, negative 3 square roots of 11. Combining my like terms with the 3 and the 2, I get 5 square roots of 12. But this is not our answer because I can simplify this 12 even further. Because 12 splits down to 3 and 4. And I know that 4 is a perfect square, so I can take a 2 out. And 5 times 2 is 10 square roots of 3 minus 3 square roots of 11. And that's the answer because you can't do anything. So adding and subtracting is relatively easy if you know how to simplify roots, which is why you need to know how to simplify roots, which is why I taught that. Please know how to simplify roots. And then the next one is the exact same. So that's just how we do things when we're simplifying radicals and roots and a little bit of scientific notation. Let's see what, I don't know if I'm going to make a video on Saturdays and Sundays. I might just take a break on the weekends. So let's see what Monday's video will be on. Let me check. Hang on, guys. To shut my binder. Monday. Oh, we get to get into parallel lines and transversals. We're getting into angles, which geometry is not exactly my strong suit, but I actually love this kind of geometry. So we're going to get into lines and stuff, which is going to suck for me to write on the board, but I'll figure it out. It'll be okay, guys. So probably until Monday, I will see you guys.